Suppose the company in previous problem uses a discount rate of 11% and a reinvestment rate of 8% on all of its projects. Calculate the MIRR of the project using all three methods using these interest rates. So the discount rate is 8%, the reinvestment rate is 11%. We have to calculate the MIRR by using all three methods, and cash flows are for 5 years, where first and last year have cash outflows and remaining years have cash inflows. So the first approach is discounting approach. In the discounting approach, we find the value of all cash outflows at time 0, while any cash inflows remain at the time at which they occur. So the discounting the cash outflows to time 0, we find time 0 cash flows minus 47,000, that is initial investment, minus 9,500 divided by 1.08 raised to power 5, that is equal to 52,638, that is outflow. So the MIRR using the discounting approach is plus 16,900 divided by 1 plus MIRR raised to power 1 plus 20,300 divided by 1 plus MIRR raised to power 2 plus 25,800 divided by 1 plus MIRR raised to power 3 plus 19,600 divided by 1 plus MIRR raised to power 4, and we have calculated that at 5% interest rate the present value is 59,926.56, and at 13% the present value is 50,268.57, and that is IL, that is present value L, that is IH, that is present value H. And if we solve this question for IRR, then the MIRR is equal to 10.82%. So by using the discounting approach, the MIRR of this question is 10.82%. The next approach to calculate the MIRR is reinvestment approach. In the reinvestment approach, we find the future value of all cash flows except the initial cash flows at the end of the project. So reinvesting the cash flows to time 5, we find time 5 cash flows 16,900 divided by into 1.11 raised to power 4 plus 20,300 into 1.11 raised to power 3 plus 25,800 into 1.11 raised to power 2 plus 19,600 into 1.11 raised to power 1 minus 9,500 into 1.11 raised to power 0. So the answer of all cash flows is equal to 97,462. So MIRR using this approach is equal to 0 is equal to minus 47,000, that is initial investment, plus 97,462 divided by 1 plus MIRR raised to power 5, and by solving this, MIRR is equal to 97,462 divided by 47,000 raised to power 1 by 5 minus 1, and the answer is 15.7%. The next approach is the combination approach, where we find the value of all cash outflows at time 0 and the value of all cash inflows at the end of the project. So the value of cash flows at time 0 is, that is combined approach, time 0 cash flows we have already computed, that is 52,638, that is in minus, and time 5 cash flows that we have computed in the previous part, that is 97,462 and plus 9,500, that is 106 962. So MIRR equation is 0 is equal to minus 52,638 plus 106,962 divided by 1 plus MIRR raised to power 5, that is equal to MIRR is equal to 106,962 divided by 52,638 and raised to power 1 by 5 minus 1, and the answer is 0.15.24%.